Now let's extend by considering this rational function. Where's the numerator 0? Well, the numerator is 0 at a couple of points. The point where negative 8x minus 6 equals 0, and that's going to be at x equals negative 3/4. And from 8x plus 8, 8x plus 8 is 0 if x is negative 1. You can easily verify that. Just set this expression equal to 0, you get, and solve, you get x equals negative 3/4. Set this equals 0, you get x equals negative 1. And of course, you should do that. Now, where's the denominator 0? You should pause and figure this out. Okay? And you should have done that now. Well, it's easily done. Set this equal to 0, and you're going to get x equals negative 1/2. You should have set this equal to 0 and solved. You would have gotten x equals negative 6. And you don't even really have to write this one out as an equation. You can see that if x equals negative 6, you're going to get 0. That one you probably want to write out as an equation. Negative 6x minus 3 equals 0. Add 3 to both sides. Divide both sides by negative 6. You get x equals negative 1/2. So I assume you've done that. You should do that for every term, just to convince yourself that I've done this right, because that's always in question. Okay, now, what do? Well, we have the zeros of the numerator, and those will be zeros of the function, unless one of the denominators has a 0 that matches the 0 of the numerator, and we're not going to worry about that for right now. But that can happen. You do have to take that into account. Doesn't happen here. Okay, so what happens near the zeros of the denominator, because that's what we got to consider. At a 0 of the denominator, x equals negative 1/2, this function isn't even defined, because the denominator is 0 and you can't define division by 0. Similarly, for x equals negative 6, it's not defined because the denominator is 0. But near these zeros, and I don't know how I wrote x equals negative 1, near the zeros of the denominator, the function is defined. And as we've seen, near a 0 of the denominator, if you're near enough, the denominator is going to be near 0. And the closer you get to 0 of the denominator, the closer the denominator gets to 0. And if the numerator doesn't happen to be 0, then the denominator is going to divide into the numerator a whole bunch of times. Maybe positive, maybe negative. Maybe positive on one side of the 0 and negative on the other side of the 0. And that's going to be the case here. So near x equals negative 6, what happens? Well, if x is less than negative 6, x minus 6 is going to be what? Positive or negative? Well, if x is less than negative 6, it should be clear that x minus 6 is going to be negative, okay? And it's x plus 6 is going to be negative. But yeah, if x is less than negative 6, then when you add 6, it's not enough to get you back to 0. Making x plus 6 less than 0. And there are other ways you can verify that. Convince yourself that this is the case. Make sure you understand why this is the case. Okay? At x equals 6, the numerator is what? What's the value of the numerator at x equals 6? Well, if x equals 6, you have negative 48 here, at negative 8 times 6. I'm sorry. And it's not at x equals 6, it's at x equals negative 6. One of these days I'll stop making mistakes on videos, but that day isn't here yet. Okay, x equals negative 6. You're going to have a plus 48 here, and minus 6 is going to be plus 42. You're going to have negative 48 plus 8 is negative 40. So it's negative 42 times 40, and that's 1,680, negative 1,680. put a question mark there because I just did that in my head, and I never want to confirm that without checking, but I don't want to take the time right now. Okay, and so that's negative. And we'd be dividing it by x plus 6, which is negative. Negative 6x minus 3 is what? Well, that's going to be 36. It's negative 33. So this whole product, negative 8x minus 6 times 8x plus 8 over negative 6x minus 3 is positive. It's also a fairly big number. 33 will go into 1680, close to 50 times. So I'll say that's near plus 50. So what's happening now? If we throw in the x plus 6 in the denominator, we're dividing whatever this gives us by x plus 6, which is a very small negative number near 0. Stop for a second to write this because I didn't want to take up much more time. This is getting a little long. So we have this is a positive near 50. So when you divide, you're essentially dividing this by x plus 6 in order to get this. So we're dividing a number that's somewhere around plus 50 by a negative number that's close to 0. So we get a large number because this is near 0. And it's a large negative result. Okay? Now, if x is on the other side of negative 6, if it's a little greater than negative 6 but close, should declare that everything we said here is true except that the denominator will be a positive near 0. So and I maybe should have paused and written that off camera, but if x is near negative 6 but greater than negative 6, then x plus 6 is near 0, now positive. And the only thing that changes in this argument is that f of x, if this is your f of x function, if f of x so f of x, which would just be this expression, is approximately equal to plus 50 over a positive number near 0, which is a large positive result. Now, that's what happens near the 0 at x equals negative 6. Near the 0 at x equals negative 1/2, what happens? Okay, I'm going to pause the video and write a couple of things down, then point to it. Try to do your own analysis. Okay, see if you can analyze the 0 near x equals negative 1/2, which makes this 0, in a manner analogous to the way we've analyzed the behavior near the 0 at x equals negative 6. The 0 of the denominator. These are zeros of the denominator. Okay, do that. I'm going to write a couple of things down here. Okay, so a very abbreviated summary of what you get, and you should work through the details and let me know if you have questions. Near x equals negative 1/2, the denominator is going to be close to 0. The rest of the function, the negative 8x minus 6 times 8x plus 8 over x plus 6, which is everything but this factor here, which is 0 at x equals negative 1/2. All the rest of the function comes out to something close to, I think, negative 1.5. It's clearly negative because this factor is going to be negative and the other two are going to easily be seen to be positive. So what happens is if x is less than negative 1/2 but near x equals negative 1/2, f of x is negative 1.5 divided by a positive number near 0. Why a positive number near 0? Well, you can verify that if x is less than negative 1/2, negative 6x minus 3 is positive. And if x is greater than negative 1/2, negative 6x minus 3 is negative. So, near x equals negative 1/2, if x is on the negative side of negative 1/2, f of x is going to be a negative divided by a positive near 0, which is going to give you a negative since you have negative over positive, and a large number since you're dividing negative 1.5 by a number near 0. So we get a large negative. And similarly, if x is a little bigger than negative 1/2, we're going to have negative 1.5 over a negative number near 0. I'm not sure that's completely legible, but that's going to give us a large positive result using just the reasoning that we've used throughout. Now, in the next clip, we'll construct the graph.